So last time we learned about econometrics, that what is econometrics, right? In previous lectures, in previous two lectures, that what is econometrics? Why do we need? What is the relevance of econometrics in our life? Then we talked that how to develop that relationship into a real form to find out some implication of that relationship. Then we looked into what's the difference between financial and economic econometrics, the basic and the very important, the key difference between financial and economic econometrics is data. In financial econometrics, we can have high frequency data, which means that we have a large number of n of population, whereas on economic econometrics, there's a problem of data availability on a high frequency. We can have yearly data for most of the variable in economic econometrics, but it's really hard to get hourly data or daily data or weekly data for macroeconomic factors to analyze macroeconomic problems. Whereas on the financial side, in a company's data, we can have thousands and millions and trillions of the data. Especially with the coming of big data, there's a huge number of data points. Importantly, the financial, for example, let's say the stock price changes maybe 10 times a day or hourly changes, right? It changes hourly. Let's not take the hourly data, let's take daily data. So if a company's issued the first time its stock 10 years ago, then it's mean like every year there are 365 days. So every 10 years there will be 3,000 and something 36,500 days, right? So there will be a plenty of data when we study or when we analyze financial, and that's the main point, that they really, the economic econometrician, they don't like financial econometrician, because they say that okay, you guys are playing too much with the data and forget the theory. But I will definitely support the financial econometrics because they have an edge, our economic econometrics. Then we also talked about types of data, that how different types of data are there. Um, Importantly, time series data, which is available over the time of the same entity with different variables. That's time series data. For example, 2000 from 2000 to 2020, the economic variables data of China, like inflation, economic growth, exchange rate, interest rate, all these are time series data. Cross-sectional data, on the same side, cross-sectional data is like at 1 year, at one point of time, but among different entities with different variables. For example, at the same time in 2020, we want to figure out that impact of COVID-19 on more than one country. That's like what happened, what's its COVID-19 impact on Chinese economy, on US economy, on England's economy, on India's economy. So we can study different economies, but at the same time, at the same point. Whereas panel data is a combination of time series data and cross-sectional data. It means like over the time among more than one entity for their different variables. When we collect that data, that's panel data. Then we also talk about ordinal data, cardinal data with the ranking, with nominal data, what's the difference between them, how to measure them. So we all talked about the types of data in our previous lectures. We also studied returns in financial modeling, that how do we calculate returns, a simple return and also compound return, continuously compound return. It's always easy to calculate simple return, and it's a bit complex to compound to get the continuous return on some assets. Then we learned about what is the phenomena, real phenomena and nominal phenomena, and how to derive the real series from the nominal data. And at the end, last but not least, we also uh, get we also got into that how to read some financial research paper, that what is important aspects to look into. Uh, First define the theoretical development that paper is contributing in the theory. What is the theory they are talking? They are making they are formulating their intuition, and then how did they collect the data, that's through primary source or through secondary source. So all these we have an overview of econometrics in our previous week. This week we're gonna go ahead. So I planned, I scheduled that this week I'm gonna talk about the software, but due to some problem in the availability of the software, I couldn't manage to distribute the copy, or couldn't manage to distribute the software. So I'm gonna skip this week with the software. There can be many softwares you can use, are Stata, SPSS, eViews. Particularly, I was supposed to talk about eViews in this class, but I'm gonna talk about eViews next week, because eViews is really friendly, user friendly, and meant to use for the econometrics to solve the econometric problems. So instead of that, we will talk about functions. So first we will talk about different approaches, different philosophical approaches and statistics. That's classical statistics and Bayesian statistics. What are these? Then we will talk about different kind of functions in today's class. So let's start with the how. First we have to talk about the economic modeling. Now, whenever we have to deal with any economic or financial problem, we need to model that, because if we don't model that, then we couldn't conclude the solutions, right? So what is modeling? It's not like walking on a ramp. That's also modeling, but here modeling is different. Here modeling means how you get the information, and based on that information, how do you probe, and after probing, how do you identify the problem, and of course then you will go for the solution. So what is the most important thing in modeling is what is the theory, what is the intuition, because you're going to model something which you have already claimed, which is in your mind, right? So the formulation, econometric modeling means the formulation of your theory. Now, that theory is not like in air. It's not a rocket science coming from the sky. You need to develop it, right? You need to develop it based on the already existed literature and theory. It is always the basic and important step to give your thoughts to a to an equation format, so that you can reach to the evidence and see that if it falls by your side or not. For example, like if you when you get the evidence, is it like gonna prove your claim, or it's gonna disprove your claim? If it is proving your case, then you go for interpretation and conclude your study for its implication. Then you have to define that, okay, that this means this, and in a practical life we can imply this in this kind of industry, in this kind of economic situation, in this kind of infrastructure. Let's see, what do you need to formulate your intuition or claim to a econometric model, so you can collect data and run. So first thing, really important, really basic, is theoretical modeling. If you don't have a theoretical model or theoretical background of your claim, it's really hard to conclude, or your conclusion will not be significant. It, it cannot be trustworthy. Nobody can believe on your expert opinion. It means you're unable to give an expert opinion. What is it? What is theoretical model? A hypothetical claim of two or more than two variables affecting in a specific way. How do you know that your hypothetical claim is based on the theory? You can only have one choice, and there is only one option, so that you know the already existed theories. And that's after reading a lot of literature. reading a lot of published work, reading already existed claims which is being proved by the economists or financial experts or the researchers. Just was checking that is everything okay. Now, it should be related whenever you build a claim, it should be related to your real life. Second thing is formulation. You got the theory, now you have to give an equation form to your theory. For example, you say that if I don't have money, I will live a poor life. So your poverty depends on the money. So how can you? Let me show you the cap. So, just, yeah. So if you say that your poverty depends on the money or income, and you have to give this theory. Now, this is your theory, this is your claim. Yeah, this is your claim. This is your claim that if you don't have money, you will live poor life. So how do you give an equation form? So that's how you formulate y equal fx, which means like your poverty depends on your income. Now, that's the formulation of your theory, right? Once you formulate your theory, now it's an easy step. You need to collect the data. You can get income data, you can get poverty data, and hence you can continue your testing. Uh, important thing here, important thing in collecting data, that from where you can get most of the data. First thing, it's already easily accessible and available, free. Most of the data is free, especially with macroeconomic data and some basic financial economic data. Uh, from where? There are different platforms, World Bank, United Nations, government official websites, government institutions. They provide you the data free of cost, um, just for the sake of research, uh, so that you can do research and you can come up with some solutions to the already existing problems. Second, some financial data can also be found on stock exchange websites, on stock exchange data portals. Reuters is a big firm which provides financial data. Or if you cannot, sometimes it's most of the time it's free, but sometimes they also take some money from you. Why? Of course, collecting data is not an easy task. You need to spend a lot of resources, a lot of financial resources, a lot of human resources, and then you collect the data. So that's why they pay. There's a debate among the researchers that some researchers say that it's not a good idea to take money from the research work. So they claim that it should be free. We can test whether that claim can be realistic or not through econometrics, but that's another thing. But if you're not willing to pay them for the data, what you can do, you can collect by yourself. But for that, you need time, you need financial resources. For example, I want to know about the class. There are like 44 students in the class, and I want to know about each and every one. That how do they live their life, everyday life. So one thing is that I can talk to your CR because your CR already has an information, right? So I can talk to your class representative and I can say, okay, you can tell me the information what you have. She will say, or he will say that, okay, you need to pay a certain amount of money because I'm gonna spend some time to collect the data for you. I will say, okay, I will pay you. Second option, no, I don't want to pay you. Then he or she gonna refuse to me by sharing the data. So what I'm gonna do, I have to collect the data by myself. For that reason, I can collect the data from whole population, or I can choose the best sample which represent the population, and I can choose take the data from there, estimated data. But that's gonna cost me a lot of time to reach out each and every student that, okay, I have some question for you, because some will say that I'm not available, some will say I cannot answer you, some will say that I'm not in the city, some will say that some means it's really hard to reach each one of them. So but this is the time taking step in any analysis. Theory you build based on already literature you have learned. Then you formulate on the basis of that literature. After that, collecting data is the problem. It's not a problem. It's easy thing, but it's a time taking thing. You can be stuck in collecting data for maybe months, like for 2 months, 3 months, 4 months. So that's why it's really important that when you are claiming some theory, you should know that is if you're gonna collect the data, is it gonna be easily available or not? Or are you willing to pay for the data or not? Right? Because data is there, but sometimes it's really it's really costly. After collecting data, now it's easy job. um, you need to learn some software. That's why I'm telling you about eViews, or Stata, or SPSS. But next week we gonna learn about eViews, that how do we use that software in order to estimate our theoretical model, right? Now, what kind of estimation you can use for it, that depends on you. You means your theoretical model. That is how you proceed mathematically before evaluating the numbers for your model. Because at the end, evidence means number, evidence means fact. You need to provide fact for your theoretical claim. For example, you can go for a single equation model. What is single equation model? You're just like learning one simple equation at one time. For example, you just want to check out that role, uh, what is the role of it on stock prices. So that's a single equation model where you can have a single equation y equal to f of x, maybe x1, x2, and so on, x3. But it doesn't matter how many variables you got. The thing is that the equation must be single. So, for example, you can say that your stock price is, is moving when there is a change in dividend. And so B1, so this is beta naught. So this is your equation, B2, interest rate, and so on. You can add up many variables. It depends what's your theoretical claim. So, but this is all using one equation. But sometimes you have to analyze two claims in your study. That's on one side you want to look into that how the stock market behaves. On the other side, how you're gonna see how the dividend or how the interest rate behaves, how the dividend behaves is a function of something, some variable, z. Now, look, because stock price is highly dependent on the dividend, at the same time, dividend is also dependent on many things, right? So sometimes you study for both so that you can interlink these two. It can be at different time, it can be at same time. When it's the same time, then it becomes so what is this? Two equation models? When you can have more than one equation to model. I mean, you have more than one claim in your theory. That's multi equation model. So here at the same time you have different equations you need to model. And if these equations are at the same time you want to analyze that, let's say if GDP of a country increases because an increase in investment, right? So what happens, what increases at the same time, let's say at 2000, in the year 2020, in the year 2020, same time, how investment will be explained. So we can say investment increase if there is a stronger financial institution, right? So at the same time, investment is being affected. Okay, sorry. Good that you told me. So at the same time, can you see now? Okay, I will also try to write in a proper way so that you can see. Okay, clearly. Yeah, I didn't put my focus on the writing. Okay, anyway, thanks for telling me. Good. So at the same time, institution, whenever we are dealing with two or more than two uh, equation at the same time, we call it simultaneous equation model. So there are three different equations we can model our theory. This one is a bit complicated. Most of you not gonna get into it during this degree, but later on when you will move to your masters, or if you want to do further research, if you're gonna join some company in order to give some financial analysis, then you need to know this. So we will talk about these things later on in later lectures, but at the moment, just for now, it's enough. Uh, let's Now we have estimated the model. Now what we get the results, right? So what are the results? Results is basically evaluation of your estimated model, right? Running the test on estimation model, that is it significant or not? Because now is the time to retrieve the results, that is parameters. As I told you, what is A, what is B, beta naught, what is B1, what is B2, how they behave, how do they work, they explain the model. Here we can see the magnitude. Magnitude means size. Means like GDP is a function of 4 times investment. It means if there is an increase in investment, there will be 4 times increase in GDP. So number four is a magnitude. Just number four is a magnitude. Same thing happens in a direction. So 4 is a positive direction, right? So it means that investment is directly related with the GDP. It's positive relation. It has having positive. And really important thing, that is this significant or not? Statistically relevant or not of the parameters achieved is according. And last, that are these all parameters explaining in the same way how theory is explaining us. And at the end, we go for the conclusion and its implication. If everything is accordingly, then we just conclude that our hypothesis cannot be rejected, and we can infer the real life scenario or the practical implication of our theoretical model. For example, if the interest rate goes down, this example is from the book, so you can get into that. that if the interest rate it goes down, this means you can buy stocks. Now it's a practical implication. So whenever the interest rate is going down, you can buy stocks, but it depends again which area, which region are you talking about. Hence, the most important thing is the theoretical model. Sometimes the theory which was given in one region cannot be affected in another region. So for that, we need to replicate that theory. That is, that theory still available? For example, if your results are not according to theoretical, so it doesn't mean that your results are wrong. It may be that that theory is not cannot be implemented in this kind of region with this kind of property. So there you need to develop another theory. So that is research, and it's keep continuing going on. If it is specified correctly, so important thing is how you formulate your claim. If you formulate it in a proper way, in a correctly specification with a correct specification, then rest of the steps are just a piece of cake and is only an exercise with numbers. How you get that? Through reading. So I suggest you read relevant published paper before thinking or before claiming anything. For example, I gave this example before as well in an earlier class is about that cooking. Like if you know how to cook, right? I okay, I guess it's my claim that most of you know cooking, right? If you know how to cook, you really know the theory behind cooking. It doesn't matter what do you cook, you will bring the taste, right? But if you don't know the theory behind the cook, that how much time you need food on the fire and blah blah blah, then I'm sure the taste will be disastrous, and you cannot give proper taste to your food. So that's really important. Now, let's move ahead with the classical versus Bayesian statistics. Now, this is really important because next whole of the econometrics, we're going to use a lot of time these classical statistics and Bayesian statistics. What is classical statistics? As from the name, it's pretty obvious. As from the name, it's pretty obvious that it's a classical. It's classy, right? Classy means old and simple. Now, it is also called, the classical statisticians are also called frequentists, right? Why? Because what do they